What about some definite integrals? The integral from -7 to -e of 1 over 3x dx. Well, the first thing I'm going to do is take that constant 3 out. 1/3 the integral from -7 to -e of dx on x. I'm just going to write it like this again to remind you that some people do write it this way and it is valid. If you prefer, you can write 1 over x dx. So that's 1/3. Now 1 over x becomes ln mod x from -7 to -e. Just a reminder, because it's a definite integral, I don't need the plus c. If I had a plus c, I would be substituting in for c and then subtracting the same constant again the second time. So we don't need a constant on our indefinite integral when we're actually doing a definite integral. So 1/3 of ln mod e, mod -e, which is just e, minus ln mod of -7. So actually, those negatives really didn't do much, did they? What's log of e? Well, log to base e of e is just 1. 1 minus, and this is log base e of 7. And if I want an exact answer, that's as far as I'm going to get, because ln of 7 is not a rational number. The integral from 0 to √3 of 3 over the square root of 4 minus x squared dx. Now, if you didn't immediately recognise that this was one of those trig rules, the √3 should also give you a hint. But it is in fact, can I find it on here, a positive over, no, square root, positive over square root of a squared minus x squared. So let's write it in this form. Take that 3 out the front. It's 3 times the integral from 0 to √3 of 1 over square root of a squared, so 2 squared minus x squared dx. So this then looks exactly like, which one? This one. So I'm looking at arc sine. Remember, I'm really looking at this side of the formula sheet. The integral of this is arc sine of x on a. So that is 3 square brackets sine to the -1 of x on a was 2, going from 0 to √3. So put in what we know. 3 times sine to the -1 of √3 on 2 minus sine to the -1 of 0 on 2. Okay, sine to the -1 of √3 on 2. What angle has √3 on 2 as its sine value? If you get stuck, draw yourself the triangle. 1, 2, √3. Sine is √3 on 2, opposite on hypotenuse, so I must be looking at pi on 3. Pi on 3 minus. Now where is sine 0? Well, in its circle, sine is the y-coordinate. It's 0 here or here. But if I'm looking at arc sine, I'm only looking at this one, because arc sine is always in this section. So it must be 0. So I've got 3 lots of pi on 3, which is just pi.